Good day! Welcome to the discussion of general mathematics about operations on functions. At the end of the discussion, you are expected to possess these knowledge skills, such as define operations on functions, identify the different operations on functions, and perform addition, subtraction, multiplication, division, and composition of functions. For our warm-up round, you are tasked to find the sum, difference, product, and quotient of the given expressions. To start, find the sum of x and x minus 2. Combining like terms, the sum is 2x minus 2. Find the difference of x and x minus 2. Changing the sign of the subtrahend and combining like terms, the difference is positive 2. Find the product of x and x minus 2. By distributive property, the product is x squared minus 2x. For the last, find the quotient of x and x minus 2. X over x minus 2 is another warm-up round. What is f of 3 when f of x equals x minus 2? So, f of 3 equals positive 1. Evaluate g of x equals x squared minus 2x at x equals 1. So, g of 1 equals negative 1. Find the value of h of x equals 3x when x equals a plus 1. So, h of a plus 1 equals 3a plus 3. I think you are now ready to proceed with the new lesson. So, let us get started. In an economics subject, the profit P of x in a certain business can be expressed by subtracting the cost C of x from revenue R of x, or in function model as P of x equals R of x minus C of x. If the revenue is expressed as R of x equals 13x squared plus 12x plus 1, and the cost C of x equals 8x squared minus 5x minus 23, how will you express the profit gained by the certain business? As you can notice, we have three functions, P of x, C of x, and R of x, and the word subtracting. So, today, you will learn how to subtract, how to add, how to multiply, how to divide one function from another function. Let us now have the definition on different operations on functions. Let f and g be functions. So we have two functions, the f of x and g of x. For the first, their sum, denoted by f plus g, is the function defined by f plus g of x equals f of x plus g of x. Their difference, denoted by f minus g, is the function defined by f minus g of x equals f of x minus g of x. Their product, denoted by f multiplied by g, is the function defined by f multiplied by g of x equals f of x times g of x. For their quotient, denoted by f divided by g, is the function defined by f divided by g of x equals f of x divided by g of x, excluding the values of x, where g of x will become 0. Why? Because the function will become undefined. 5. The composite function, denoted by f circle g, or f composed with g, is the function defined by f composed with g of x equals f of g of x. First, we will be discussing about the sum of two functions, denoted by f plus g of x equals f of x plus g of x. So, let us have these functions. F of x equals 3x, g of x equals x minus 2, h of x equals x squared minus 2x plus 1. Task number 1. Perform addition of functions. Now, you are tasked to find the sum of f of x and g of x. And f plus g of x is equivalent to f of x plus g of x using the definition of addition on functions. F of x plus g of x equals 3x came from f of x plus x minus 2 came from g of x. Simply replace f of x and g of x with the respective expressions. Now, f of x plus g of x, simply combining like terms, 3x plus x minus 2 is 4x minus 2. Thus, the sum of f plus g of x equals 4x minus 2. Now, you are tasked to find the sum of g of x and h of x. We know that g plus h of x equals g of x plus h of x. Now, g of x plus h of x equals x minus 2 plus x squared minus 2x plus 1. Now, g of x plus h of x is equivalent to x squared minus x minus 1. Simply combine like terms. Task number 3. Find the sum of h of x and g of x. We know that h plus g of x equals h of x plus g of x. Now, h of x plus g of x equals x squared minus 2x plus 1 plus x minus 2. Now, h of x plus g of x equals x squared minus x minus 1. Now, let us check these two examples. G of x plus h of x and h of x plus g of x. What did you notice about their sum? Very good. They have the same result. According to this property, If the numbers are added in any order, the result is the same. And what is that property? Very good. Commutative property. And commutative property is applicable over addition. Now, we will learn how to find the difference of functions. So for your task number 4, find the difference of f of x and g of x. We know that f minus g of x equals f of x minus g of x. Now, replace f of x and g of x with their respective expressions. So f of x minus g of x equals 3x minus quantity x minus 2. Don't forget to enclose your subtrahend using open and close parentheses because there will be a change in sign in our subtrahend and we will proceed with addition. Just like this, 3x from minus sign to plus sign, and from positive x to negative x, from negative 2 to positive 2, and it will become 3x minus x plus 2. Now, simplify by combining like terms. F of x minus g of x equals 2x plus 2. For your task number 5, find the difference of g of x and f of x. You already know that g minus f of x equals g of x minus f of x. Now, replace g of x and f of x with the respective expressions. X minus 2 minus 3x. So, x minus 2 from minus sign to plus sign, and from positive 3x to negative 3x. And it will become x minus 2 minus 3x. So, for the final answer, g of x minus f of x, it is now negative 2x minus 2. For your task number 6, you need to find the difference of h of x and g of x. From the definition of subtraction of functions, we have h minus g of x equals h of x minus g of x. Next, replace h of x and g of x with the respective expressions. X squared minus 2x plus 1 minus quantity x minus 2. So, as I have said a while ago, minus sign, from minus sign to plus sign, and then from positive x to negative x, and from negative 2 to positive 2. That is why we have x squared minus 2x plus 1 minus x plus 2. Combining like terms, h of x minus g of x equals x squared minus 3x plus 3. Again, let us take these two examples. F of x minus g of x and g of x minus f of x. What did you notice? Very good. The answers are not the same for both functions. Therefore, subtraction of functions does not follow the commutative property. So remember that f of x minus g of x is not the same as g of x minus f of x. Moving forward, we will now be discussing about the product of functions. For your task number 7, perform multiplication of functions. Number 1, find the product of f of x and g of x. We know that f multiplied by g of x equals f of x multiplied by g of x. Next, f of x multiplied by g of x equals quantity 3x multiplied by x minus 1. So we use parentheses to indicate that our operation is multiplication. So I just replace f of x and g of x with their respective expressions. Using distributive property, we have 3 of x multiplied by x is 3x squared, and 3x multiplied by negative 1 is negative 3x. So that is the product of f of x and g of x when your function f of x is equal to 3x and g of x equals x minus 1. Now for your task number 8, find the product of h of x and g of x. H multiplied by g of x equals h of x times g of x. Next, h of x times g of x equals quantity x squared minus 2x plus 1 times x minus 1. Using distributive property over multiplication, x squared multiplied by x is x cubed. X squared multiplied by negative 1 is negative x squared. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 is positive 2x. Positive 1 multiplied by x is positive x, and positive 1 multiplied by negative 1 is negative 1. For our final answer, simplify by combining like terms. H of x multiplied by g of x equals x cubed minus 3x squared plus 3x minus 1. For your task number 9, find the product of g of x and h of x. G multiplied by h of x equals g of x times h of x. Now, g of x times h of x equals x minus 1 times x squared minus 2x plus 1. Using distributive property of over multiplication, x multiplied by x squared is x cubed. X multiplied by negative 2x is negative 2x squared. X multiplied by positive 1 is positive x. Next, negative 1 times positive x squared is negative x squared. Negative 1 times negative 2x is positive 2x. And negative 1 times positive 1 is negative 1. Combining like terms, the final answer is g of x times h of x equals x cubed minus 3x squared plus 3x minus 3. Now, let us take these two examples. H of x multiplied by g of x and g of x multiplied by h of x. What did you notice? Good. According to the commutative property of multiplication, if the numbers are multiplied in any order, the result is the same. Therefore, commutative property is applicable over multiplication. So remember, h of x multiplied by g of x is the same as g of x multiplied by h of x. Now, we will now discuss the quotient of functions. For your task number 10, find the quotient of f of x and g of x. F over g of x equals f of x divided by g of x. F of x over g of x equals 3x over x minus 1. Simply replace f of x and d of x with their respective expressions. F of x over g of x equals 3x over x minus 1. So since we cannot simplify it further, the final answer, the quotient of f of x and g of x is 3x over x minus 1. For your task number 11, you need to find the quotient of g of x and f of x. G over f of x equals g of x divided by f of x. And g of x over f of x is equivalent to x minus 1 over 3x. Simply replace g of x and f of x with their respective expressions. For the final answer, x minus 1 over 3x. Since we cannot simplify it further, the quotient of g of x and f of x equals x minus 1 over 3x. For your task number 12, you need to find the quotient of h of x and g of x. H over g of x is equivalent to h of x divided by g of x. And h of x over g of x equals x squared minus 2x plus 1 over x minus 1. Since we can express x squared minus 2x plus 1 in x minus 1 squared, then we have x minus 1 multiplied by x minus 1 over x minus 1. Since we x minus 1 divided by x minus 1, this one is cancelled out. Therefore, f of x over g of x is equal to x minus 1. For your task number 13, still on the division of functions, f over g of x equals f of x divided by g of x. F of x divided by g of x is equal to 1 over 3x all over x minus 1. To simplify, 1 over 3x times 1 over x minus 1. Simply get the reciprocal of denominator, then proceed with multiplication. And f of x divided by g of x equals 1 over 3x multiplied by x is 3x squared, and 3x multiplied by negative 1 is negative 3x. Or f of x divided by g of x equals 1 over 1 multiplied by 1 is 1 over 3x multiplied by x minus 1. Again, let us take these two examples. F of x divided by g of x and g of x divided by f of x. What did you notice? Okay, the answers are not the same for both functions. Therefore, division of functions does not follow the commutative property. Remember that f of x divided by g of x is not the same as g of x divided by f of x. For the last, we will now be discussing the composite function denoted by f composed with g is the function defined by f composed with g of x equals f of g of x. For the next task, you need to operate on composition of functions. So we have f composed with g of x, and that is equivalent to f of g of x by its definition. Next, f of g of x, as you can see here, g of x will be our replacement value or the input value. So all the x variables in the function f will be replaced by function g. So let us have this. Let us use this function 1 over 3 multiplied by x. So instead of writing x, it will be replaced by the expression from the function g. So 1 over 3 multiplied by x minus 1. As you can see, the green color will be our g of x and the red color will be our f of x. So replace f of x and g of x with their respective expressions. And then to simplify, so it is simply operate on the denominator. So f of g of x equals 1 over, by distributive property over multiplication, 3 multiplied by x is 3x and 3 multiplied by negative 1 is negative 3. So that is how we operate on composition of functions. For the next task, find g composed with f of x, and that is equivalent to g of f of x. So as you can see here, g of f of x, the replacement value will become f of x, or the input value is f of x. So all you need to do is to replace all the variables of x in g by f of x. So you will use g of x. Instead of writing x minus 1, you will write 1 over 3x minus 1, because x will be replaced by 1 over 3x. So to subtract fraction numbers, all whole numbers have 1 as their denominator. So 3x, to subtract it, here are the procedures. 3x divided by 3x is positive 1, multiplied by positive 1 is positive 1. 3x divided by 1 is 3x, multiplied by negative 1 is negative 3x. So for the final answer, g of f of x is equivalent to 1 minus 3x over 3x. As you can see, g composed with f of x is not equivalent to f composed with g of x, or g of f of x is not equivalent to f of g of x, because they will not come up with the same result. Therefore, commutative property is not applicable over composition function. Next task, another composition of functions. Find h composed with g of x. And we know that it is equivalent to h of g of x. And as you can see here, g of x will be our replacement value or the input value. So all the x variables in h will be replaced by g of x. So you will use h of x, and then all x variables will be replaced by x minus 1. So instead of writing x squared, you will write x minus 1 squared. And then instead of negative 2x, it is negative 2 times x minus 1. Copy the constant number 1. Then to simplify this, x minus 1 squared minus 2 quantity x minus 1 plus 1 is equivalent to. So you can operate this like this process, or in this manner. X raised to 2 is x squared. Then 2 multiplied by positive x multiplied by negative 1 is negative 2x. Negative 1 raised to 2 is positive 1. Then negative 2 multiplied by positive x is negative 2x. Negative 2 multiplied by negative 1 is positive 2. Then just copy the constant number. To simplify, combine like terms. So x squared, negative 2x plus negative 2x is negative 4x. Then positive 1 plus positive 2 plus 1 is positive 4. So final answer, h of g of x is equivalent to x squared minus 4x plus 4. Now, let us combine evaluation of function and operations on functions. Your task number 14 is to find h minus g of negative 2. So here, x equals negative 2. So we will just rewrite negative 2 as x. H minus g of x is equal to h of x minus g of x. So h of x minus g of x equals x squared minus 2x plus 1 minus quantity x minus 1. And then we have h of x minus g of x equals x squared minus 3x plus 2. So h minus g of negative 2 is equivalent to negative 2 squared minus 3 multiplied by negative 2 plus 2 equals 4 plus 6 plus 2. And h minus g of negative 2 is equal to 12. Another way of answering task number 14, to find h minus g of negative 2, it is equivalent first to h of negative 2 minus g of negative 2. Evaluating h at negative 2, it is h of negative 2 equals negative 2 squared minus 2 times negative 2 plus 1. Simplifying these numbers, h of negative 2 equivalent to positive 9. And also, we need to evaluate g at negative 2. So, g of negative 2 equals negative 2 minus 1. And g of negative 2 equals negative 3. Then, h of negative 2 minus g of negative 2 equals 9 minus negative 3. For the final answer, h minus g of negative 2 equivalent to positive 12. As you can see, we get the same answer using this method. Now, I will show you how to answer this kind of problem the easiest way, I think. Why? Because you will go directly on operations on functions as well as evaluation of function. So let us have this example. F divided by g of negative 1 is equivalent to f of negative 1 all over g of negative 1. So we use f of x. So we have this, we evaluate f of x at negative 1. So we use this expression, but we replace x by negative 1 already. So 1 over 3 multiplied by negative 1. So our denominator now is g of negative 1. So we will use this function. So we evaluate this function at negative 1. So directly, g of negative 1 is equivalent to negative 1 minus positive 1. And to operate this kind of problem, dividing fraction, so we copy the numerator, then get the reciprocal of the denominator, and then proceed with the multiplication. Actually, we can answer this as this way, using this way. So 1 over 3 multiplied by negative 1 is negative 3. So we have negative 1/3 multiplied by negative 1/2. So we have for the final answer, f of negative 1 divided by g of negative 1 is equivalent to positive 1 over 6. Let us now take this example, task number 16. So we need to find the product of f and g of 2. So it is equivalent to f of 2 times g of 2. And f of 2 times g of 2 is equal to, using the function of f of x and g of x, we need to evaluate both function at x equals 2. So replacing x by 2, we have 1 over 3 multiplied by 2 and 2 minus 1. Since the operation is multiplication, we use open close parentheses and brackets as our to indicate or to denote that the operation is multiplication. So we have this, simplifying this, 1 over 3 times 2 is 1 over 6 and 2 minus 1 is positive 1. So 1 over 6 times positive 1 is positive 1 over 6. So the product of f and g of 2 is equivalent to 1 over 6. Next, for task number 17, find f plus g of a plus 1. As you can see here, our replacement value is a binomial including a variable a. By its definition, f plus g of a plus 1 is equivalent to f of a plus 1 plus g of a plus 1. Next, f of a plus 1 plus g of a plus 1 equals. So our f of x, replace x by a plus 1, it is 1 over 3 quantity a plus 1 plus, then our g of x, so it will become g of a plus 1, replacing x by a plus 1, it is a plus 1 minus 1. We can actually cancel out positive 1 and negative 1, so it will become 1 over 3 quantity a plus 1 plus a. Next, to add, get the LCD. The LCD is 3a plus 3 quantity a plus 1. So 3 quantity a plus 1 divided by 3 quantity a plus 1 is 1, multiplied by positive 1 is positive 1. And 3 quantity a plus 1 divided by 1 is 3 quantity a plus 1, multiplied by positive a, it is 3a quantity a plus 1. So simplifying this using distributive property over multiplication, we have f of a plus 1 plus g of a plus 1 equals 3a squared plus 3a plus 1 over 3 quantity a plus 1. For your task number 18, so find f composed with g of negative 3. And we know that it is equivalent to f of g of negative 3. So for this problem, you need to first evaluate g at negative 3. So g of x equals x minus 1. Replace x by negative 3. It is g of negative 3 equals negative 3 minus 1. And that is equivalent to g of negative 3 equals negative 4. So instead of writing f of g of negative 3, knowing that the value of g of negative 3 is negative 4, you will simply write f of negative 4. So you will be using f of x and replace all x variable by negative 4. And f of negative 4 is equivalent to 1 over 3 multiplied by negative 4. And that is, f of negative 4 is equivalent to 1 over negative 12 or negative 1 over 12. Going back with this problem, and that is we need to find the profit p of x by subtracting c of x from r of x. So since our c of x is represented by a function 8x squared minus 5x minus 23, and our r of x is represented by 13x squared plus 12x plus 1, and as you can see, our operation is subtraction, so we have subtraction on function. So here, in subtraction of function, as I have said a while ago, we need to enclose the subtrahend in an open close parenthesis, because we will change the sign in subtrahend and we will proceed in an addition. So p of x is equivalent to 13x squared plus 12x plus 1, which is the value of r of x, minus c of x, which is 8x squared minus 5x minus 23. So 13x squared plus 12x plus 1 plus, actually positive 8 will become negative 8x squared, negative 5 will become positive 5x, and negative 23 will become positive 23. So combining like terms, p of x is equivalent to 13x squared minus 8x squared is 5x squared, and 12x plus 5x is 17x, and then the constant number positive 1 plus 23 is positive 24. Therefore, the profit gained by the certain business is represented by this function, p of x equals 5x squared plus 17x plus 24. And here are my references in creating this material. Thank you to Versosa and Mastin. So again, thank you guys for listening. God bless, and please be COVID free.